Today we're going to do the chi-squared test for independence. A few days ago we did the expected counts, and today I'm going to do the total test for whether age groups like different types of ice cream. So to recap, it was 25, 15, and 8 for a total of 48. We had 32, 24, and 5 for a grand total of 45, and 18, 18, and 9 for, that was a total of 61, and a total of 45. And at the bottom we had 25, 57, and 22. The expected values were chocolate, vanilla, strawberry, 4 to 9, 10 to 13, 14 to 17. We had 25.1, 17.8, and 6.9, 29.7, 22.6, and 8.7, and 21.9, 16.7, and 6.4. If you want to quick remember on how we can get the expected counts, you do row total times column total divided by the good old total. Alright. So the population here is all kids. And the parameter is the percentage, or proportion if you prefer, of each group that likes each type of ice cream. And just so we can understand why I'm calling this a chi-squared test of independence, each kid was asked 2 questions. 1, they were asked their age. 2, which type of ice cream. Remember, if we only asked one kid and we had the groups already split up, then you go watch the other lesson, the other chi-squared test of homogeny. Alright, so of course I'm going to put down alpha equals 0.05 because ice cream isn't that serious, so I'm not going to have a big problem if we don't have a proper test, because unless you work for Ben & Jerry's, and then you may want to know a little bit more information. So, conditions. We got a simple random sample. For the purpose of this, it was in the problem. Independence. We have a large population of children whose choice doesn't affect each other. The expected values I'll go through the two that are normally come up. All are greater than 1, more than 80%, greater than 5. Because actually we could have said that all of them were greater than 1, but these were the two that you want for the expected value. So those are the two expected value conditions. So now we can put our chi-squared. You always want to put down the formula, since we're probably not going to write out all 9 of them. Let me erase this so that I give myself enough room. We got the actual minus the expected squared divided by the expected. So we start out with 25.1 squared, or 25 minus 25.1 minus 25 squared. Alright, 25 minus 25.1 squared divided by 25.1. Hope you stuck with me through all that. Plus 17.8 minus 15. I did it again. 15 minus 17.8 squared divided by 17.8. The really important part is that we get the bottom part right. Plus, let me do it one more time so that I can show you that I can do this right every once in a while. 8 minus 6.9 squared divided by 6.9 ... And I get a total of 4.42. And I'm going to put my degrees of freedom down here, which is 3 minus 1, rows minus 1 times columns minus 1. So 3 minus 1 times 3 minus 1 turns out to be grand total of 4. Now the nice thing about chi-squared is it's always greater than. Come back here, check our number, 4.42. And I get 0.352 by using the chi-squared CDF. From 4.42 to a billion. That's enough zeros with 4 degrees of freedom. Since my p-value is greater than 0.05, I fail to reject the null hypotheses. I do not have enough evidence to state that ice cream choice is dependent upon age in children. Alright, that's one lesson for you. Thanks for watching.